The quadratic expression 6x square positive 11x positive 4 can be written as 3x positive a times 2x positive b, where a and b are integer constants. It can also be written as 3x positive c times 2x positive d, where c and d are non-integer constants. What is the value of a positive c? Okay, here we have a quadratic expression. Actually, when I look at this stuff over here and here, clearly this both are the factor form of this quadratic expression. Okay, in the first factor form, 3x positive a times 2x positive b, this a and b are integer constants. In the second way, the quadratic expression written in factor form over here, so this c and d are non-integer constants, and we have to find the value of the expression a positive c. Since we have the factor form of the quadratic expression over here and here, so now what we can do is we can try to factor this quadratic expression. Let me write the stuff. There is 6x square, positive 11x, positive 4. Okay, now, so to factor this quadratic expression, we have to multiply the constant positive 4 by the coefficient of x square, that is positive 6. When I multiply this positive 4 by this 6, I am getting positive 24. Okay, now what I have to do is I have to get two factors over here, so that the product of two factors equals to positive 24. And when I add these two factors, it must be equal to the coefficient of x, that is positive 11. So that we have to get two factors over here. I think positive 8 and positive 3 will work. When I multiply positive 8 and positive 3, I am getting positive 24. When I add positive 8 and positive 3, I am getting positive 11, which is a coefficient of x. Okay, now further I have to divide these two factors by the coefficient of x over here, that is 6. Let me divide this one by 6 and this one by 6. Now positive 8 divided by this 6 can be written as 3 times 2 over here, and here positive 3 over this 6 can be written as 2 times 3. Okay, now let me take x over here and x over here. Now I am moving this 3 as a coefficient of x over here. Then I am getting 3x positive 8 divided by 2, because this 3 is taken as a coefficient of x over here. And when I divide 8 by 2, I am getting 4. Then I am getting 3x positive 4 as a first factor for this quadratic expression. Let me write over here. Okay, now in this one, what I'm going to do is I'm going to move this 2 as a coefficient of x. Then I'm getting 2x positive 3 over 3. So 2x positive 3 over 3 means like 2x positive 3 over 3 will become 1. So this is the second factor of the quadratic expression, that is 2x positive 1. Okay, now I got the factor form of the given quadratic expression, 6x square positive 11x positive 4. Okay, now look at the numbers we have over here, 4 and 1. Both of them are integer constants. That is, these two factors are in this form, 3x positive a times 2x positive b, because in this one only we have a and b are integer constants. So at the place of a and at the place of b, we have positive 4 and positive 1. That is, I got the value of a equals to positive 4 and b equals to positive 1. Okay, now what I'm going to do is I'm going to do the same stuff again. That is, let me take this positive 24. Let me get the two factors, that is positive 8, positive 3, the same thing. Then I divide both the factors by the coefficient of x square, that is 6. Then I do 8 over. So this time also I'm going to write this 6 as 3 times 2, and here positive 3 divided by 2 times 3. Okay, so here when I did the problem, I just took this 3 as a coefficient of x over here. But in this case, I'm going to take this 2 as a coefficient of x over here. So when I move this 2 as a coefficient of x over here, then I'm getting 2x positive 8 divided by 3. And also the same thing, let me take x over here. This time I have to take this 3 as a quotient. But when I did the same thing, I did a first number. I took this 2 as a quotient of x, but this time I have to take this 3 as a coefficient of x over here. So when I move this 3 as a coefficient of x over here, I'm getting 3x positive 3 divided by 2. So here 8 is not divisible by 3, so I have to keep this fraction as it is. Here 3 is not divisible by 2, so I have to keep this one also as it is. Okay, now let me write the other way of writing this quadratic expression in factor form. The first factor is we can write this 3x positive 3 over 2. Let me write it. And the second factor is 2x positive 8 over 3. Let me write it over here. Okay, now look at the numbers over here and here. Both of them are non-integer constants. We can look at the other way of writing the given quadratic expression in factor form, that is 3x positive c times 2x positive d. So in this one, both c and d are non-integer constants. So here we have 3 over 2, 8 over 3 are non-integer constants. So comparing this and this, at the place of c we have 3 over 2, at the place of d we have 8 over 3. So we have C equals to 3 over 2 and D is equal to 8 over 3. Okay, our aim is to get the value of A positive C. Okay, now I have the value of A, that is 4, and the value of C is 3 over 2. So now to get the value of the expression A positive C, I have to add this 4 and 3 over 2. So then I'm getting 4 positive 3 over 2. Okay, now to add the integer 4 and the fraction, what we have to do is we have to multiply the integer by the denominator of the fraction. Whenever I want to do addition or subtraction between an integer and a fraction, the integer has to be multiplied by the denominator of the fraction. Once I'm done with this multiplication, I can take this 2 as a common denominator. Okay, let me multiply this 4 by 2, then I'm getting 8 positive 3. So now we can take the 2 as a common denominator. 8 positive 3 is 11. That is 11 over 2. Now I got the value of this A positive C. The value of A positive C is 11 over 2.